This is the first in a series of videos looking at ultrasonic flow meters. This video deals with the theory. Subsequent videos will deal with the specifics of the Panametrics PT878 Ultrasonic flow meter. The Panametrics PT878 uses a technique called time of flight. This technique will be specifically covered here. There are also other instruments which utilise the Doppler effect to measure flow using ultrasonics. Ultrasonic signals are highly directional. Providing the pipe material and the fluid in the pipe conducts ultrasonic signals, an ultrasonic signal transmitted across the pipe can be received on the other side of the pipe. When we have a signal sent simultaneously from both sides of the pipe, the signal travelling with the flow will arrive faster than the signal travelling against the flow. To measure the difference in the arrival time, we will simply look at the phase shift between the two signals. This phase shift difference is directly proportional to the speed of the liquid in the pipe. This relationship is a function of how far apart the transducers are and the flow profile of the liquid in the pipe. The flow profile is pretty much a constant for laminar flow. For us to get both of these signals across, we have to firstly place the transducers very accurately on either side of the pipe. To do this, the refraction angles of the ultrasonic signal as it passes from one medium to another need to be known. This refraction angle is a function of the speed of sound in each of the materials. We also have to ensure that none of the materials through which this ultrasonic signal passes excessively attenuates or disperses the ultrasonic signal. Therefore, we need to know, is the pipe full? Excessive bubbles or particulates in the pipe will disperse the signal. Is there laminar flow? Because if it's very disturbed flow, again this will disperse the signal. Typically, you'll have laminar flow when you have 10 diameters upstream and 5 diameters downstream from the flow meter, clear of any obstructions. We need to know the speed of sound in the pipe and the liquid for the refraction angle calculation, the physical dimensions such as the wall thickness and pipe diameter. Also, because of the mechanical considerations in mounting the transducers, we can extend the path of the ultrasonic signal. A single traverse, a double traverse, and finally a 4 traverse. All of this complexity boils down to a pretty simple procedure. 1. Enter the pipe material, diameter and wall thickness, or nominal diameter and pipe schedule. Enter the fluid type, enter the number of traverses. The flow meter then subsequently calculates the transducer spacing. We then place the transducers on the outside of the pipe at the spacing calculated by the flow meter. We also need to place an ultrasonic couplant between the transducers and the pipe because an air gap will stop the ultrasonic signal. We are now ready to log the flow rate of the liquid in the pipe. We have not cut the pipe. All we have done is simply enter a few mechanical details and attach the transducers. The next video in the series will specifically deal with setting up the Panametrics PT878 Ultrasonic flow meter.